All right, so section 6.5 is looking at actual trigonometry. So we're going to look at the trigonometric ratios, okay? And like I said with last section, it's pretty much impossible to do if you cannot do the labeling. So please make sure that you understand section 6.4, and if you have any questions, you let me know, okay? And before we start, I wrote out something here on the side. I wanted to go over with you guys what I mean by a ratio, because sometimes I even catch myself thinking, oh, like what is that ratio? What are we actually talking about here? Okay? So when you see a ratio, so for instance, we've looked at ratios, I'm going to write it up here, about like 1 to 2. Let's say you see that ratio. Okay? What does that mean? So a ratio between two or more numbers is simply a way of measuring the size. So all we're doing is we're measuring the size of each number compared to one another. Okay, so we're comparing two numbers. So for instance, if we look back at 1 to 2, or if it was a decimal of 0.5, that actually tells us that one number, so the number 2, is twice as big as the other number, which is the number 1. Okay, so that's all a ratio is doing. And when we are looking at the trigonometric ratios, we're going to be looking at ratios based on 3 mathematical functions, which are sine, cos, and tan. And we're going to start with the tangent ratio, okay? And this is actually where we get SOHCAHTOA from, okay? So we're going to start with the tangent ratio, and then we're going to move on from there. So to start with the tangent ratio is a ratio between the side that is opposite to your angle, okay? So remember, angle A can be anything. It could be theta, it could be alpha, it could be beta, but essentially it's whatever the internal angle is that they tell you is your angle of interest, okay? So your internal angle of interest, is what they mean by angle A. So it's the ratio between the side opposite angle A to the side adjacent to angle A. And we practiced labeling opposites and adjacents in the last section, section 6.4. And it is called the tangent ratio of angle A, or sometimes more commonly we'll just say tan A or tan theta. And it's usually, we write it as a fraction, okay? So ratios can be written 3 ways. We could have, I wrote over here, I did the ratio way and I did the decimal way. But the other way we could have written that as 1/2, okay? So that's the fraction way. And then we express it as a decimal, which you guys have seen, usually to 4 decimal places, okay? So what we're looking at here then is we are looking at the ratio between the side that is opposite the angle and the side that is adjacent to the angle, okay? Now, this is the length of the side. When I say the side opposite here, I mean the length of the side, okay? So you can move from tan A to angle A by looking at numbers in a table. So back in the day, it sucked and you had to look at numbers in a table to figure out, you would be given an angle and then you would look up a number in the table to find the ratio, or you can have a calculator do it for you. And we're going to show you how, or I will show you how to do that. But what you need to remember is that tan of your angle, whatever angle that might be, tan of your angle is going to be the ratio between the opposite side over the adjacent side. I already explained where you find those. So the adjacent side here. Oh my goodness, I really did not spell this correctly. Okay, one sec. Adjacent side. Okay, and the tan ratio is the one we call TOA. So when you hear SOHCAHTOA, TOA is the tan ratio, right? Where the T means tan of the angle, the O is the opposite, and you can see there's a fraction over the adjacent. Okay, and I just abbreviated those. So for example, we're going to use our calculator to find the tangent or the tangent ratio of the following angles. Okay, so to do this, you have to make sure, get rid of that your calculator has been set to degrees. If your calculator is not in degrees, and what it should have is it should have something that says DEG up in the corner. If it's not in degrees, then you are going to get the wrong answer, and it's not going to be a great time. Okay, so make sure it's set to degrees. Usually there's a setting on your calculator that'll let you change between them. The other ones that you don't want, so we do not want radians, so we don't want RAD. So there'll be one that shows up as RAD in the top of your calculator. We don't want that one. And we also don't want gradients, which are GRAD, okay? So on your calculator, usually, I'm just gonna be a bad calculator, you'll find it like right up in the corner here, and you want it to say DEG, okay? If you have any trouble with that, let me know and I can help you figure that out, because you're always gonna get the wrong answer if your calculator is not in degrees. So if we take our calculator, and depending on what kind of calculator you have, unfortunately, there's going to be a different sequence of buttons. Okay, I cannot spell today, I'm so sorry. Depending. Depending on what kind of calculator you have, there's going to be a different sequence of buttons. And unfortunately, it's not standardized. I do not know why, but you're going to either have to put into your calculator, you're either going to push the button that says tan, and then you're going to push the button for 2, and the button for 0, and the button for equals. Okay, so like that. Or if you have a different kind of calculator, you may have to put in 2, 0, and then push tan. Okay. Again, if you're having calculator issues, let me know and I can help you figure it out. But these are the two options. I don't think I know of any other options. And the tan button, so let me just see, I'm just gonna see my calculator here. My calculator app has a good calculator on it. Maybe it doesn't. Scientific, okay. So for instance, if I wanted to do tan of 20, now usually they have SOHCA and TOA, or sine, cos, and tan buttons, but here I gotta go in here. So I'm gonna press tan, and then I'm gonna press 2, and then I'm gonna press 0, and I'm gonna press equals. Now, clearly this calculator wants me to put in the 20 first before I do the tan. So let's clear and try again. I didn't know this. All right, so 2, 0. We're gonna do it the opposite way. 10. Hey, there we go. Okay, so 0.36397. Now I said we usually go to 4 decimal places, so it's fine to stop after that. So 0.36397, blah, 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 blah. What we would stop at, we would round her up to 0.3640, okay? So this is the ratio between the opposite side and the adjacent side for tan of 20 degrees. If it's a 20-degree angle, this is the ratio between the two sides. That's what that means, okay? This is the ratio between opposite and adjacent side if there's a 20-degree angle. So if I were to just quickly here, let me show you what I mean. This was 20 degrees, and this is the opposite side, and this is our adjacent side, okay? So opposite over adjacent, the ratio between the two would be 0.3640. All right? And that becomes really important because we can use it to find all sorts of different things. All right? So the ratio between the two side lengths. So the length, I just want to make sure that's clear, the length of O over the length of A. All right? All right, now let's go. So you have a bunch of different examples. I'm going to put in the answers, and I would like you guys to try and take some practice and do it on your own calculator, okay? So you can check your answers after, but please make sure you are comfortable putting this in your calculator. Okay. And then please just remember 4 decimal places, okay? If you're wondering, it's just like a standard way of writing out tan, cos, and sine ratios. Okay, so 4 decimal places. Our next example says find tan theta, so tan of the angle, as a fraction and as a decimal to 4 decimal places. Okay, so tan theta, so let's find theta, okay? Now, we want for tan, we want the opposite side and the adjacent side, right? So this is our opposite side, this is our adjacent side, and this is our hypotenuse. So the hypotenuse is not going to matter for tan, okay? So then we have our angle of interest, right? So we have to always, sorry, I should have done that first. Angle of interest. You always have to be relative to the angle of interest, but we've practiced labeling, so we have opposite, we have adjacent. So we know that tan of that angle of interest is going to be equal to the opposite side over the adjacent side, okay, which is going to be equal to 8 over 6. And if we're expressing it as a fraction, we need to reduce it. So in order to reduce this, we are going to divide each side by 2. Okay, so that's 4 over 3. So that will be our answer as a fraction. And then as a decimal, to put it in decimal, we just do 4 divided by 3, right? And that gives us 1.333, repeating on and on forever. Okay? So our steps are still going to be to label, right? Pick out the right sine, cos, or tan. Right now they're asking for tan. So we're going to write out the formula, and that's what this is. And then we're going to sub in our numbers. So it's pretty much the same. Sub numbers and solve. Okay? So if we have a go at this one here, first thing we've got to do, figure out our angle of interest. So I see it right there. This is our angle of interest. I need to label my triangle. So I have my opposite side. I know my hypotenuse is across from the right angle, and I know whatever I have left is my adjacent side. Okay, so the sides that I'm going to care about here for tan are the opposite and the adjacent. Now I'm going to write out my formula, which is that tan of the angle theta is going to be equal to opposite over adjacent. Okay, and so that is 60 over 63. Okay. We can divide each of these by 3 if we want to make it smaller. So 20 over 21 would be the reduced fraction, and you should always try and reduce your fraction. And then 20 divided by 21 is going to equal 0.9524. Okay, so that's our answer as a decimal to 4 decimal places. All right. So next we have the sine ratio. Okay, so there's going to be 3 ratios that we look at: tan, sine, and cos. So we're going to do the sine ratio next. All right. So for the sine ratio, we're going to look at the side opposite A, or opposite your angle, over the length of the hypotenuse. Okay. So the ratio, again, of the side opposite the angle A over the length of the hypotenuse depends only on the size of the angle. That's the only thing we care about. Doesn't matter how big your triangle is. You could have a triangle that's giant, so you could have a little triangle with an angle of 20 degrees, or you could have a gigantic triangle with the angle of 20 degrees. And looking at these, you can see that this one's bigger, right? But opposite, hypotenuse, adjacent, opposite, hypotenuse, adjacent. So you would know that like this hypotenuse compared to this hypotenuse, that one's probably longer, right? but it actually doesn't matter. The ratio is always the same. Okay, so doesn't matter the length. What matters is the angle. Okay, angle size matters. All right, so that's what they're saying there. All right, so the ratio is called the sine ratio, okay? And it's often, we drop the E, I don't know, just I guess make it only 3 letters. So sine ratio of angle A, or angle theta, or whatever angle you want, the angle of interest, or more commonly, we will say sine of A, where A is your angle of interest, okay? Again, written as a fraction, expressed as a decimal, so sine of your angle is equal to the length of the opposite over the length of a hypotenuse. So just remember that these values here are the length. Okay, again, you can look up numbers in a table, which is super boring, or we can do it on the calculator. Okay, so let's do it on the calculator, and this one we call SO. So the last one was TOA. This one we refer to as SO because, and SOHCAHTOA TOA is a way to remember them. Okay, so sine is opposite over hypotenuse. Okay, so that's why that one is called SO. All right, so let's do some examples, but I really want you to make sure you get that when I put in sine of theta equals opposite over hypotenuse, or sine of A equals opposite over hypotenuse, I'm going to keep saying this, but please know that A and theta, they just mean are representing the angle of interest. That could be any letter, number, whatever is representing the angle of interest. Okay? So don't get freaked out when you see different letters there. It just means angle of interest. And I personally don't like using letters, so you'll notice that I do this a lot more than use letters. Okay? But they're just a placeholder for whatever that angle number is, right? So whatever number in degrees is this part right here. Okay, that's going to be your angle of interest is theta or A or beta or gamma. There's many things they could call it. Okay, size of angle. It's just a placeholder. Okay, so they're placeholders and they're pretty interchangeable until you actually get a number. Okay, so same rules apply for calculator. So except now you're going to press the sign button. So I'm going to fill these out, but again, I encourage you to try and do them yourself first, and then check your answers. We're still going to go to 4 decimal places. Okay. And then I knew that my calculator is backwards, so if I'm going to try, hello, come up. If I'm going to try and do one of these myself, so let's say I'm going to do the first one, sine of 20, I know I need to put the 20 in first for my calculator because it's annoying, and then press sine. Okay, so 0.3420, that's what I put down there. Okay, 0.3420. All right, so let's try now and do some ratios here. Okay. So it's the same way as we did before. We identify our angle of interest. Okay. We label our triangle, so opposite the angle of interest. Hypotenuse, which we know. You'll notice these triangles have the same lengths on them as the ones we did for the tangent ratio, but because now we're using sine, we're interested in the opposite and the hypotenuse. Okay, so those are the two that we care about. So write out our formula. Sine of theta is equal to the length of the opposite over the length of the hypotenuse, which in this case is equal to 8 over 10. And if we reduce that, dividing by 2, top and bottom, we're going to get, 4 over 5. So as a fraction, 4 over 5. And then as a decimal, the ratio of sine theta for this triangle will equal 0.8. Okay, that's 4 divided by 5. All right, so the sine ratio for this triangle, we're going to label it first, opposite, hypotenuse, adjacent. Again, these are the same numbers, but now we're looking at the sine ratio, not the tangent ratio for the angle theta, which is right here. That's our angle of interest. We know that sine theta is interested in opposite, length of opposite over length of hypotenuse, which in this case is 60 over 87. Okay, that cannot be reduced, so that's that. And then if we do 60 divided by 87, we get the actual decimal number, 6897. Okay? All right, and you'll notice I'm kind of going a bit quicker now just because it's actually all very repetitive. It just depends on whether you're using sine, tan, or last but not least, we're going to look at the cosine ratio. So the cosine ratio is the last one, and the cosine ratio is involved with the length of the side adjacent to the angle over the length of the hypotenuse. Okay, again, we only care about the size of the angle. We don't care about the size of the triangle, so everything is the same, except it's cosine now. So cosine ratio of angle A, except we're going to just drop the cos, we just call it cos A, okay? So again, we write it as a fraction, express it as a decimal, but we know that cos of A or cos of theta, in this case, is going to equal the length of the adjacent over the length of the hypotenuse. And that one is ka. Okay, so ka. That's our last one, where this is the cos. Okay, this is the adjacent, or cos of the angle, equal to the adjacent divided by the hypotenuse. Okay, so again, we're looking just at the size of that ratio, or the value for that ratio. So practice in your calculator. I'll do the first one with you guys. So cos of 20. So 20 cos. So 0.93969, blah, 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 blah. I'm going to round that up here to 4 decimal places. So 0.9397. Okay, but you guys try and figure the rest of these out yourself. And then you can check your answers, but you definitely need to practice, okay? All right. So let's do our last step here. So find cos of the angle as a fraction and as a decimal. All right, same thing, same triangle even. Okay, angle of interest. Opposite side, okay, hypotenuse. The labels don't even change because the angle of interest is in the same place. So I know that cos of my angle is equal to the adjacent over the hypotenuse, which is going to be 6 over 10, or 3 over 5, okay, as a decimal, or sorry, as a fraction. And then as a decimal, 3 divided by 5, we are going to get 0.6 as our decimal, okay? Again, on here, angle of interest, label our triangle, opposite, hypotenuse, adjacent. I know the ratio of cos of our angle is going to be equal to the adjacent over the hypotenuse, which in this case is 63 over 87. I cannot reduce that fraction, okay? But I can change it into a decimal, which is 0.7241. All right, so now we've gotten through so, ka, and toa. Now, you might be asking yourself, why? Why do I care? Why would I bother figuring out these ratios in a triangle? All right, now the reason why we do this is because sometimes you don't have both the angle and all 3 sides. So sometimes you don't have the angle, sometimes you don't have 3 side lengths, and you need to find the missing side lengths or missing angle, okay? And it can actually help you calculate like distances between things. For instance, if you know the angle you are looking at, let's say you're standing here. Okay, I'll give you guys a practical example because I want to just lead into this next part. I'm going to get a new blank page. All right, so this is the why that we do this. Let's say you are casually hanging out. You're super pumped. You are flying a kite, okay? And your kite, I know kite flying is something that definitely happens all the time these days. Your kite, sadness, gets stuck in a tree. Oh no, okay? So now your kite is stuck in this tree. And you're like, what do I do? Okay? Let's say you call your mom and your mom's like, hey, I'll bring you a ladder. And you're like, okay, but how tall a ladder do I need? And let's say your mom's asking you, how tall a ladder do you need to get up that tree? Well, you can figure this out a couple of ways. You could measure the tree, but that might be too difficult, okay? Might be too hard to measure the tree. But if you knew this angle, so let's complete the triangle here. If you knew the angle that you were at looking at the top of the tree, so if you knew this angle and you know the distance between yourself and the base of the tree, let's say the distance, let's say you're 20 feet back from the tree, you can actually solve how tall a ladder do you need. Okay, so you could figure out what this height is just from these 2 pieces of information. Let's say you were at a, I don't know, what's a normal angle here? A 40-degree angle to the top of the tree, and it was 20 feet. Well, if we turn this into a right angle triangle, okay, we know that we don't know the hypotenuse, so that's too bad, but we do know the adjacent, and we know the angle, and we're looking for the opposite. So if I know the angle, I could say that tan of my angle is going to tell me the length of the opposite over the length of the adjacent, right? And tan of 40, because that's my angle, will tell me the length of the opposite, which is x. We don't know how long that is, but we do know the length of the adjacent, which is 20. Now, this is a spoilers for the future. We can actually make that look, and I know you guys are really excited about this because you love ratios. If we put tan 40 over 1, we can actually turn this into a cross multiplication situation where you multiply the pair and divide this pair, right? Because you've got tan 40 times 20 divided by 1. And because we can solve for this value, the ratio of tan 40 of opposite over adjacent, we can actually solve for this missing x. And so if your mom calls you and you ask, how tall a ladder do you need? You can give her the answer in a very complex way. But I actually used this the other day to build a fence, so it is useful, okay? So that's all I'm going to do for today. I'm almost at half an hour. Okay, thanks.